Let's start off simple. In your head, I want you to picture a nerve. And I want you to ask yourself, is this nerve a motor nerve or is it a sensory nerve? What you need to understand is that they both exist. Now, within our motor nerve system, there are nerves that are thicker, there are nerves that are thinner, there are some that are myelinated, and there are some that are unmyelinated. Same thing within the sensory system. There are ones that are thicker, thinner, myelinated, and unmyelinated. Let's talk about the naming of nerves. We like to group things, that way we can categorize information. Understand that any nerve that's found in the body that is within the diameter of 13 to 20 micrometers and it's myelinated, whether it's afferent or efferent or motor or sensory, this nerve is going to be called an alpha nerve or a group 1 nerve. Follow along in the chart. Any nerve, whether it's motor or sensory, if it has a diameter between 6 and 12 micrometers and is myelinated, it is going to be called a beta or a group 2 nerve. And the list goes on. You could just read the rest of the chart yourself. So just to clarify, there are alpha motor neurons and alpha sensory neurons. There are beta motor neurons and beta sensory neurons. Delta motor neurons, delta sensory neurons, C motor neurons, and C sensory neurons. With this being said, if you're dissecting a cadaver and see a nerve with a thickness between 13 and 20 micrometers and it's myelinated, you could potentially be looking at either a motor or a sensory nerve. Let's talk about the order at which these nerves are listed in this diagram. As you can see at the very left, we have the thickest nerve and it's myelinated. And as we move towards the right, we get thinner nerves with less myelination, and the last one doesn't have any myelination at all. Regardless of the size of the nerve and whether or not it has myelin, understand that all nerves do the same exact thing. All they do is send information. It doesn't matter if I'm sending sensory information. It's still information, electrical impulses. It doesn't matter if it's a motor nerve. It's still sending information through electrical impulses. What makes nerves different then from each other and why they have different diameters and whether or not they have the presence of myelination is the speed at which information is sent. The thicker the nerve is, aka the larger the diameter is, the faster it's going to send information from the central nervous system toward the muscles, aka for a motor nerve, or it's going to send information faster from the skin or from organs, etc., to the brain. So I'm talking about sensory nerves in this example. The thicker a nerve is, the faster it sends information. The thinner a nerve is, the slower it sends information. Now, if a nerve has myelin, it will send information faster. If a nerve does not have myelin, it will send information slower. So it should make sense that when we double it up with a thick nerve as well as the presence of myelin, that the alpha nerve, the one at the very left, whether it's motor or sensory, this one will send information to its target faster than it would the C fiber, whether or not it's a C motor or a C sensory fiber due to that thinner diameter as well as the absence of myelination. Now we're going to talk about the functions of these specific nerves. What's shown right here on this chart is purely sensory nerves, so that's what we'll talk about on this slide. What researchers have found is that nerves that happen to be thick and myelinated, so under these alpha sensory nerves, these nerves are going to give information about proprioception. As we continue to move towards the right of the picture, we move on to beta nerves. These are a little bit thinner compared to the alpha group, but they also still have myelination. And because they're thinner and because they have less myelination, as you can see, they don't travel as fast. But the function of this sized group of nerves is for mechanoreceptor information. So think about vibration on your skin, touch, pressure, everything that mechanoreceptors tell your brain. We move on to delta. Still talking about sensory, right? These happen to give information about pain and temperature. This information, once again, is not as quickly sent to the brain as proprioceptive information or mechanoreceptor information, again, due to the size, due to the presence of myelination. Lastly, we have the C fibers. This doesn't have myelination at all, so it should make sense that the information sent from these nerves, which happens to be pain, temperature, itching, reaches the brain last. So between delta and C fibers, you'll see an overlap. They both tell the brain pain information as well as temperature information. One of these reaches the brain a little bit faster, and one reaches the brain a little bit slower. So here's an example. Let's say you touch a piping hot piece of steel and it's been baking in the sun. You're going to get two types of sensations. You've probably experienced it yourself. You're going to get that immediate ooh ouch, that burns. And then after a couple seconds, you get that more dull, diffuse, ooh, that stings. So the two different pieces of information that you're getting is first from the faster, ooh, that hurts information from the delta nerve, and then that later slow diffuse burn information coming from the C fibers, the one that travels a little bit slower to the brain. Let's talk about motor functions with respect to specific sized nerves. Now, the first one is the one that we're most familiar with, most commonly talked about, the alpha motor neuron. This is the one that tells our muscles to contract, so efferent information. Then we move along towards the right, and we have things that are just less commonly discussed. This includes the beta motor fiber. This one sends information to the autonomic nervous system. And as we move further to the right, delta. We actually do not have delta motor fibers, but we do have what's classified as class 3 as well as class 4 motor fibers. And these also have involvement with the autonomic nervous system. Here's a summary. Motor and sensory nerves have different sizes. Within the motor system, there are nerves that are thick, there are nerves that are thin, there are ones that are myelinated and ones that are unmyelinated. Same thing with sensory nerves. If a nerve is thicker and it's myelinated, it is going to send information much faster than those that are thinner and unmyelinated. Through a bunch of incredibly smart researchers, we have found that nerves of certain sizes and certain thicknesses and the presence and absence of myelination have a purpose for specific functions. Let's discuss some application. Some words might have rang a bell to you, such as beta, delta, mechanoreceptors, speed of information travel. This should ring a bell for the concept of gate theory. Mechanoreceptor information travels faster than pain does towards the brain. So with all that we've talked about, why don't we take advantage of this information and maybe assist with things like pain management? If you enjoyed the way the content was broken down to where you could truly understand it, check out our courses at sptwithme.com when you're studying for the NPTE.